This is the Building Automation Monthly Podcast with Phil Zito, episode 124. Hey folks, Phil Zito here, and welcome to episode 124 of the Building Automation Monthly Podcast. And in this episode, we're going to be talking about wireless communication for building automation. Outside of how to tune PID loops, this is probably one of the most misunderstood topics when it comes to building automation systems. We've flirted as an industry with the idea of wireless systems for better than a decade now. We've gone from wireless to mesh to point, and to everything in between. But yet, for whatever reason, there just hasn't seemed to have been widespread adoption of wireless technologies. I mean, on the surface, you would think, man, this makes perfect sense. I don't have to run wires. Yeah, I have to run my power wires, but I don't have to run wires. There's even sensors that, using light or other various things, batteries, etc., can power themselves. This is the best of both worlds. It would reduce my cost per point, or my electrical cost, depending on how you structure your costs, substantially. So in an ideal world, this would be something we would be all over, right? But yet, it still seems to be an area within the industry that is just not being fully utilized. Yeah, there are definitely products out in the marketplace that are good quality products that are delivering wireless solutions. But at the same time, when you talk to the majority of BAS professionals and you ask them about wireless, and you're sitting having a beer with them or a coffee, whatever you drink, and you're sitting down with them and you're saying, hey, what do you think about wireless? They go, yeah, it's good, but I really prefer wired. I prefer something I could put my hands on, something that I can touch and troubleshoot. In my experience, that comes from really two things. One is the requirements of wireless design are greatly misunderstood, and that results in projects that are substandard from a wireless perspective. You see, wireless is not something you can just go put out there. You actually have to think through, especially if you're utilizing wireless, Wi-Fi, or mesh technologies. You have to think through your placement of both sensors and controllers. But also, from a troubleshooting perspective, it's something that is quite difficult to troubleshoot. When you think about it, if my MSTP trunk is down, I have multiple steps that I can go and take to troubleshoot that. But if my wireless system is down, how do I go about troubleshooting that? So in this episode, what we're going to be doing is we're going to look at the four major wireless technologies. Those are Wi-Fi, mesh, cellular, and point-to-point. We're going to talk through at a high level what each technology is, kind of how it's being utilized in the industry, and we're going to talk through the pros and the cons of each technology as well, and we'll give a couple examples. Now, I myself have worked with all four of these technologies, and I've seen the pros and cons. Each one has its own unique use case and benefits, and we're going to be going and covering those as we go through this episode. If you've ever wondered about wireless, you really wanted to get your mind around it, but you just haven't had that information, then this is the episode for you. So let's dive in with our first topic, Wi-Fi. So unless you've been living under a rock, you've probably been using or have used Wi-Fi within the past week. This technology is widely used, and I would say it's almost the exclusive use technology for accessing networks in most office buildings and just most buildings in general. So what is Wi-Fi, and why do we use it in the building automation space? Well, Wi-Fi exists to extend the wired network. What it does is it utilizes these things called access points. And access points, essentially, if you think back to how you install most supervisory devices, right? You'll take like a 16 by 20 NEMA 1 panel, you'll put a supervisory device in there, and you may put a 5-port Linksys switch or something similar to that. what that switch is doing is that switch is connecting to a network upstream, and that's a single port network. And then downstream at that switch, it's got usually 4 or 5 ports itself. Well, what an access point does is an access point physically connects, usually via an Ethernet cable, to a network switch. And then that access point allows devices to access the wireless network. And how it does it is it goes and has these channels, essentially. That's what they're called. And these channels exist within a bandwidth range. Two of the most common bandwidth ranges are 2.4 and 5.0 gigahertz. And depending on the bandwidth range you're using, you can have more channels or less channels. The 2.4 gigahertz access range has less channels than the 5.0 gigahertz range. Now, why does this matter to you? Well, what happens at these access points is they essentially have a cell, for lack of a better word. And within this cell, all the devices connecting to that access point utilize a channel. And then the access points next to that access point, from a network perspective, have a different channel. That way there's not channel overlap. And as you go from space to space, the access points hand off to one another, and this is managed by a wireless LAN controller. Essentially, you connect to a network ID, and that network has its own subnet, and it issues out IP addresses to wireless devices. Now, from a building automation perspective, that's all well and good. Problem is, our devices don't really move that much. And wireless is a very popular technology, and it is in most buildings. It's not always the most suitable technology for building automation systems. The pros with wireless are that it's very common. As I mentioned, it exists in almost every building. It's very well understood, as well as being very easy to use. You simply have an SSID or a wireless network set up, and then that wireless network allows you to connect devices to it, and those devices are issued IP addresses. However, wireless does come with several cons which limit us from a BAS infrastructure perspective. First of all, there's a lack of redundancy. If that AP goes down, then it's down. This isn't like mesh where you have self-healing networks and devices will route to another node. No, if the access point goes down, then the cell coverage in that area often dies with it. Another issue with Wi-Fi is that, especially if you're using a shared access point, which is kind of the golden, what's the word I'm looking for? I can't even remember that phrase I'm looking for. It'll come back to me. But if you are like saying to yourself, hey, I'm going to use the access points that are in this building because they're already there. What you're not counting for is, are all these people watching YouTube and Facebook and whatever else, and maybe it's March Madness and they're streaming on ESPN.com across the wireless, and all of a sudden all this congestion, this data overload on this wireless network starts to impact your BAS. Because remember, at the core, the access point has a access link going to the switch from the wireless access point. And there is a limitation on the bandwidth that can travel across that link. So you can have congestion. Now, another issue is that quite often with wireless access points, we use DHCP. Now, DHCP, Dynamic Host Configuration Protocol, where IP addresses are essentially leased to network interface cards, is not that big of a deal with field controllers and things like that, because most of the IP controls these days support DHCP. However, when we start to talk about supervisory devices and we start to talk about things related to BACnet, that's where utilizing static IP addresses becomes much more reliable and is much more supported. So there is the con of most wireless access points are set up to utilize DHCP, and convincing the IT folks to issue static IP addresses out of an access point is a hard argument to win. And then we have sensitivity to interference. And this coincides with one of the biggest issues with wireless, at least Wi-Fi wireless, is that you often don't have control of where the access points are placed. Oftentimes, they are not involving the building automation contractors and saying, hey, Mr. and Mrs. BAS person, where would you like to put the access point? No, that is not often given consideration. So you're at the mercy of any interference as well as the access point placement location. Quite often our controls are in mechanical rooms, which are giant rooms surrounded by concrete and sheet metal with a lot of electrical interference. That does not bode well for wireless. Now, you can use wireless, and when I say wireless, I've got to be careful. I'm talking about Wi-Fi here because there's multiple types of wireless. It does not bode well for Wi-Fi to have your controller in a concrete box with a sheet metal top on it, and then expect a wireless signal to travel from one access point that's most likely in a hallway through some metal doors to reach your controller. That's why you will see quite often wireless access points are utilized in open office areas, and they're utilized with buildings that don't have a lot of interference. That's why you'll see other technologies within hospitals and things like that are being used for networking, usually hardwired. With all of that being said, as I mentioned, the design is outside of your control. So you're often not going to have Wi-Fi where you need it all the time. Now, if this is an office building, not a really big deal. But if this is a hospital or a university or somewhere like that, you're often not going to be very practical to utilize Wi-Fi. But there's a solution to that, and we'll talk about that in just a second. Now, an example of Wi-Fi utilization with that are building automation system, a very common example is if you've got an open area office space that has Wi-Fi in it, then utilizing that Wi-Fi to connect to field controllers that are in the plenum, because there's line of sight between those controllers and the access points. You don't need line of sight from the access point to the controller, but it sure helps the signal that it doesn't have to bounce off walls and try to get through sheet metal. So with that being said, if you've got open access, you've got wide open spaces, Wi-Fi can be really nice. If you've got potential for interference or you're trying to reach controllers that are in mechanical rooms with no access point around, things can be a little bit more difficult. Also, if you're working in the commercial office space, commercial real estate space, and it's a multi-tenant situation where the tenant's providing their own wireless infrastructure, then you've got to be cognizant of that as well, because anytime a tenant finish out happens, that network infrastructure may change, and that may impact your ability to have your BAS controls, which are dependent on the Wi-Fi, actually to be communicating. So you've got some issues there that often folks don't plan for in the multi-tenant space. All right, with that being said, let's dive in to mesh networking. So mesh networking is where multiple nodes, which are both devices and networking devices. So they're both control devices and networking devices at the same time. And what happens is, it depends on the form of mesh you are using, but typically you will have a master node, and that node will be connecting to the physical network. And then you have all of these other nodes that connect to that master node. And sometimes you'll have multiple master nodes. And what happens is that if one of these nodes goes down, the messages will route throughout the network utilizing a dynamic routing protocol. So basically, just like how IP routing is dynamically determined, you also have the physical routing, which is dynamically determined as well. So that is how mesh works. Now, these nodes, they act as relays, as I mentioned, and they relay to each other node. Now, here's the cool thing about it. Since it's utilizing a peer relationship, it's less sensitive to the actual design of the network. So it's not as important where you put these. I mean, you still have length and communication barrier issues that you need to worry about. So you can only communicate so far, and you can't go and just blast through a solid steel wall with your communication. But at the same time, it's much more forgiving if you do lead one node a little bit too far, and then there's another node, they can start kind of compensating for that with their routing algorithms. So the pros of a mesh network are that, one, they're failure resistant, not failure proof, but resistant, in that as long as you have multiple master nodes connecting to the physical network, then you could potentially have multiple paths to get back to that network in case a single node were to fail. They're less dependent on the wired network, whereas with APs and Wi-Fi, you have your one kind of connection to the wired network, whereas with mesh, you can have multiple connections to the network. And usually they're not saturated with data because mesh is typically used for sensor networks and it's kind of standalone. And you're starting to see it more, actually. We've got a mesh system at our house that we use for wireless, and you're starting to see more and more folks using mesh, but it's still not a very common technology, which is one of the cons. It's less common, so it's less likely that it's going to be something already installed. It's something you're going to have to install yourself. It's a little more difficult to troubleshoot because of the self-healing and dynamic routing nature of the network. The messages aren't determined to go a single path, so it's a little more difficult to troubleshoot if you've got communication issues. And you still have to do some planning in order to lay out this network. It's not as intense as Wi-Fi, but it still requires some planning. Now, how I've seen mesh used and how I've used mesh personally is utilizing mesh sensors that go to a hardwired controller. This is where you may have 2 or 3 sensors using something like Zigbee or N-Ocean, and they are connected back to a controller. Or you may actually have mesh sensor controller combo where both of them are using mesh communication technology, and then one of the controllers is maybe a supervisory device, or one of the controllers has a hardwire back to the network. So that's how I've seen these being used. Which brings us to our third technology, which is cellular. Now, cellular, it wasn't really very common to see cellular until the past couple of years. Now you're starting to have these cellular providers who have unlimited data, 3G, 4G connections, which 3G provides more than enough bandwidth for BAS data. And the purpose of a cellular modem is to allow a device or a system to connect to the internet. Now, whereas up to this point, Wi-Fi and mesh were used for inter-building communications, so for a LAN, a local area network, when we start to see cellular, what we're really looking at is kind of wide area communication. So if you want a back end into a piece of device, say you got a smart building equipment controller or a smart equipment controller, and you want that to connect to the cloud, you could use a cellular connection. If you want a dedicated backlink to your BAS for remote access in case the building network goes down, you could have a cellular connection with a switch that if the network goes down, it switches over to the cellular connection, so you always have access to the building automation system. Now, the pros of this are that it can act as a backup network, and it's fairly independent of IT. You can kind of set these up on your own. Now, the cons of these are, one, they're relatively expensive. I mean, they're still expensive compared to the other network technologies. And the other con is that you have very limited troubleshooting because you are dependent on an outside party. The people who maintain the cellular network are the folks you're dependent on, and quite often they're not going to be helping you troubleshoot why their cell tower isn't working. It's either up or it's down. So examples of how this has been utilized, I've used this to use it as a back end to buildings for remote access, and also used it on smart equipment or just a dedicated connection to a specific BAS controller. Finally, we have point-to-point communication. Now, the purpose of point-to-point wireless is that you have a directed line of sight in wireless systems from one device to another. The purpose behind this is, let's say you have a building that is 400 meters or, a quarter of a mile or something around there away from another building. Well, you can use microwave line of sight and point to point. I was trying to say both of them at the same time. You can use that communication to go from that one main building to a farther away building. And the benefit of this is it allows you to extend the BAS network to this device. Now, the cons are these are usually quite expensive. They require a high level of technical aptitude in order to install and operate, and they are difficult to troubleshoot. Now, I've used this in the past quite a bit on remote buildings where wanted to have a chiller plant or something or a cooling tower, something like that needed to be communicated to, and it was a far off building, could use point-to-point microwave, and it's pretty reliable, and it's definitely high speed enough for what we're doing, but it does definitely cost a fair amount of money. So to recap, you have 4 main wireless technologies. You have Wi-Fi, mesh, cellular, and point-to-point. And all of these technologies can be utilized with specific use cases. And you need to be cognizant of those use cases and then position the right technology based on the pros and cons in the use case you're trying to achieve. To recap on the use cases, typically we use Wi-Fi when we want to utilize the existing network that's in place, and we want to utilize it for access to the network via our controllers. This is typically in open areas that are tolerant to, or that have line of sight to the device and don't have electrical interference or some sort of physical structure interfering with communication. Then you have mesh, which allows more flexibility. It also allows self-healing nature. This is more tolerant in certain sites that have physical design issues that would prohibit Wi-Fi. The only thing I will mention, one more thing about mesh, is that since it's a newer technology, at least for most folks, a lot of folks are concerned in high-risk buildings, healthcare, government, about having mesh because they just don't necessarily trust the technology. Then you have cellular, that's mainly used for backlinks into your systems, and point-to-point, which is used for communicating locally to relatively far away pieces of equipment. All right, folks, thanks a ton for listening to this podcast, and you can find everything that was discussed along with the show notes and links to the IT episodes that were before this episode that will really help you kind of further drive home your IT knowledge. You can find all of that at buildingautomationmonthly.com/124. Once again, that is buildingautomationmonthly.com/124. We also have a free 4-lesson IT course that you can enroll in at that page. Just kind of scroll down, look for the free IT course hyperlink, click on that, and enter your email, and you'll be able to enroll in that. Thanks a ton for being here. Can't wait to talk to you again this time next week. Take care.